Hello, this is Dr. Az. In this video, I would like to show you how to use Python for bigger size models to find the shortest path. I'm in our Blackboard. When you scroll down, I want you to download the CSV file. Also, I want you to download the Python file. Then you can go to your browser, internet browser, and search Google Colab. And here, make sure you are signed into your Gmail account. And I would like to browse the file that we just downloaded. And then click on this folder button and wait for it to connect. And then upload the CSV that we just downloaded. Okay. So now, again, you may not be able to understand everything in this code, which is not in the scope of this class, but I want you guys to be able to use this code. So first step, you can see here, we use import CSV to import the CSV file that we have to read the data. And it will read the data for this data set from to cost. These are three columns in the CSV from original node and then this destination node. And these are the costs associated with each edge. And then we will build a map on net or network in Python from the CSV. And then we'll use Dijkstra's algorithm to find cheapest way to travel from beginning till the end. And at the end, we will print the route and total cost. And again, to be able to run this model, you want to make sure that the CSV file column headings are exactly like this from to cost. And it's a one-way connection directed network, meaning that there's only one way going from one node to another. But if it's a two-way, meaning if you can go back and forth from that node, you may want to change certain things in this spreadsheet in Python code. And we are creating right now a path, shortest path from A start point to G end point, but you can change this. So once we import the CSV file here, then we can change certain settings. Like we can change the name of the file here. If in exam I give you a different file name, you need to change this. And if I ask you to connect start node of not A, another letter, or not G, another letter or word, you need to update these. And again, if I give you directed map instead of undirected, you need to make this true instead of false. So you can see here, then what we will do is read the CSV file and we will start with empty map, which is we create a map of adjust ADJ and it's a empty map as you can see. And this is called dictionary, and dictionaries are more like each key plays, like for example, in this case, A, B, C, D, all the way to G has a pair. Like for example, adjacent A, node A's adjacent ones are B and C, letter B and letter C. That's why they're in quotation. And the costs associated with these edges are 4 and 2 respectively. And then we will open the CSV file safely. And again, don't worry about this too much, but new line here makes sure that um, different types of computers, Macs and Windows and Linux, they have hidden letters at the end to go to the next line. So we want to eliminate that. That's why we just use that. And F closes safely those files if we need to close them. So again, don't worry about this, but we will just use it the way it is every single time when you run this model. And this code right here will read each row a dictionary using the column name. So we create the dictionary here, And then we'll read every single row in our CSV file to add to that dictionary. And now this is how we go through each row and add edges. So for row in reader, because we read this from CSV file, but we don't know how many rows we have, because again, we are writing this code flexible enough. Every spreadsheet will be different, and we will record those rows, how many rows we have. Again, Python starts with indexing 0, by the way. Just I want you to remember that, meaning the first row and first column is not index 1, it's index 0. And then we define here u and v variables. And the u variables will come from column, which is the first column. And v variable will come from to column in our spreadsheet. And then the strip here removes any accidental spaces so that we don't create a mess when we deal with our data. And then we have W's, which are our costs. And this is going to be float, which means decimals, potential decimals. And we get that from cost column, which is the third column. And then we will add one-way edge from U to V because it's a one-way graph. There is no traffic from V to U, only from U to V. And then if there is no key in this given spreadsheet, we'll create a blank one to keep it consistent. For example, here you can see that all the U's will have at least something like it's empty. If there is nothing from that specific node, we will still specify as blank instead of just not putting it at all. And we do the same thing for V, but for V, as you can see, everything will be blank because it's a one-way graph. But if it's undirected, meaning that if we can go from U to V and also V to U, then we can turn again this one on right here. And if we do that, we can do the same thing for the undirected version as well, so that we have all those weights associated with both directions. Well, now we can apply Dijkstra's algorithm. And again, our goal in Dijkstra's algorithm to find cheapest cost. And first we initialize it. To initialize it, we assign infinite cost to all the nodes except start. And then we initiate a new list, which is called previous. And this will be helpful for us to create our path. And we will also create a list of set of places that are done, which means they are assigned, they are permanent, or they are finalized. And what we will do is we will keep doing this while loop while we can improve our cost for that node. And again, we will choose the smallest cost for that step in our Dijkstra's algorithm. And then if we still have infinity, we will just keep trying. But if we cannot really improve anything, we want to stop the code. And if we reach to the end node, that means that we already found the cheapest route. So we are done. We don't need to keep running the code. And then at that point, we just finalize our cost and path. And this is how we try to improve each neighbor by relaxing it. And if the cost is cheaper again, we just remember the previous node. and we update the distances. So that once we are done with running the Dijkstra's algorithm, we can create the route, and we'll go backwards where we keep track of things from end to beginning and we put them together here. Again, don't worry about it. The code itself, just I'm just giving you high level. That's all you need to know how to run this. And then at the end, we will need to reverse it because we don't want to go from finish to start. We want to go start to finish. And then we will print the results like this. Okay. And let me just run this model for you. And you can see that the shortest path is go from A to C, C to B, B to E, E to F, and finally F to G. So you can see to reach from A to G, this is the shortest path, and total cost for this path is $16 or 16 days or 16 risk profile, depending on what is those numbers mean. So it doesn't matter, but it's just some kind of cost. That's it for this video. Until next video, enjoy business analytics.